Welcome back, students. In this video, we'll work on compound inequalities. Look who's joined us at the math table. It's Bruce the cat. Bruce's 23 pounds of orange love. Compound inequality problems use the words and or. When we do our work, we are to solve, graph, and then show our solution in interval notation. Let's start with a compound inequality that uses the word and. This part of the problem says that we should cover up numbers that are less than 5. Let's put 5 here. And then in my mind, I'm covering up numbers that are less than 5. Notice that I'm not on my graph yet, because this is only half of the problem. Look at the other half. This says cover up numbers that are larger than -1. We'll put -1 here. Numbers that are larger than -1 would be these numbers. Again, I'm not on my graph yet. For my graph, I want to cover up numbers that are both less than 5 and greater than -1. I don't want these numbers because these numbers are only greater than -1, not less than 5. I don't want these numbers because these numbers are only less than 5. They're not greater than -1. I want numbers that are both at the same time, which are numbers that are covered by both lines. I want everything from -1 up to 5 because these are things that are covered by the first line and by the second line. Here's my solve. Here's my graph. For my interval notation, what things have I covered up on my graph? I've covered up everything from -1 to 5. Everything from -1 to 5, everything on this line satisfies that inequality. Let's try a second example. Now on this one, I must solve each side of the problem first. To solve, get rid of the 7. The inverse of subtraction is addition. -7 and +7 is 0 plus x. -9 and +7 is -2. Let's solve here as well. To solve, I'll divide by -3. -3 divided by -3 is +1x. -12 divided by -3 is +4. And don't forget, in an inequality, when you divide or multiply by a negative number, the inequality symbol flips over. Each problem, we are to solve, graph, and give the interval notation. Here comes the graph. Look at this part of the problem. We are to cover numbers that are bigger than -2. Let's get 0 on my graph and 4 on my graph. And numbers that are bigger than -2 are numbers to the right of -2. Notice I'm not on my graph yet. This I'm just doing in my head. I'm thinking about this half of the problem. Now let's think about this half of the problem, where I'm supposed to cover up numbers that are less than or equal to 4. Numbers that are less than 4 would be this way. Numbers that are equal to 4, I would include that dot. Now what goes on my actual graph? I need things that are covered up that satisfy this part and satisfy this part. Things that are covered by this line and are covered by this line. Well, the only things that are covered by both lines are the things that are in between. Everything in here is covered by both this line and this line, covered by both of them. Let's cover those up. Now, do I color in this dot? Well, it would have to be covered by both lines. -2 is not covered by this line, so I don't want it. Do I color in the 4? Well, is it colored in on both lines? This line clearly covers the 4, and this dot is closed in, which means I want the 4. For my interval notation, what have I covered up? I've covered up everything from -2 to 4. But when I color in the dot, when I have an equal bar, I show that with the strong bracket. I've covered everything between -2 and 4, including the 4. Here I've shaded everything between -2 and 4, including the 4. Numbers that are in this solution satisfy that compound inequality. Bruce seems to have lost interest. I don't think Bruce is at all that good at math after all. In the last two problems that we did, our compound inequalities use the word and. These use the word or. Or works very differently. Let's give them a try. For this first problem, look at the left-hand part. I'm to cover numbers that are less than or equal to -3. Here's -3. Numbers that are less than or equal to -3 would be numbers to the left of -3. Because of the equal bar, color in the dot. This half says cover numbers that are larger than 2. Numbers to the right of 2. That would look like this. And again, with the equal bar, color in the dot. Now, what does the word or mean? Or means if it's covered by this line, we want it, or if it's covered by this line, we want it. Either or. So for my real graph, I want things that are bigger than 2 or smaller than -3. Each one has an equal bar, so I color in both dots. On my interval notation, what is it that I've covered on my graph? As I go left to right, I've covered everything from -infinity all the way up to -3. I colored in the -3, so strong bracket. Or I also color in everything from 2 continuing out to infinity. When I make my interval notation, I think left to right, from -infinity to -3, and from 2 to positive infinity. From -infinity to -3, or from 2 to positive infinity. Let's try this one. I should solve both sides. I'll divide by -8. -8 divided by -8 is 1x. 16 divided by -8 is -2. But remember, when you divide by a negative number, the inequality symbol flips over. To solve here, the inverse of subtraction is addition. -5 and +5 is 0 plus x. 0 plus 5 is 5. Let's try the graph. This side of the problem says cover numbers that are less than -2. That would be to the left of -2. No equal bar, so don't color in the dot. This half of the problem says cover numbers that are greater than 5. That's to the right of 5. But again, no equal sign, don't color in the dot. The word or means if it's covered by this line, we want it. Or if it's covered by this line, we want it. Now for my interval notation, I've covered up everything from -infinity to -2. Soft parentheses because I don't want the -2. Or I've covered things from 5 to infinity. Soft parentheses because I don't want the 5. For this last example, I want you to think of the word between. Things that satisfy this must be between -3 and 6. Let's solve. Think of this as two separate problems, all built into one. We need to get x by itself in the middle, so get rid of the 15. The inverse of addition is subtraction. We'll subtract 15 from each part of the problem. -3 and -15 is -18. 15 minus 15 is 0. We still have the 2x. 6 and -15 is -9. Now divide by 2 on each part of the problem. 2 divided by 2 is 1x. That's what we wanted, is x by itself. -18 divided by 2 is -9. -9 divided by 2, I'll just show that as -9/2. If I were to take 9 and divide it by 2, that's the same as -4.5. I've completed the solve step. Now let's make the graph. Remember, I'm using the word between. I want to be between -9 and -4.5. Here's 0. -9 would be there. -4.5 would be there. And I want the things that are between. Numbers that are in here, if I plug them back into my original inequality, would satisfy that inequality. Now, I shouldn't forget, I have an equal bar, so I color in the dot. An equal bar on this side, color in the dot. Finally, for my interval notation, what have I covered? I've covered all the numbers between -9 and -9/2. All right, that looks great. Your turn. Go work some homework problems, then meet me back here.